Cities are no longer expanding, they are being engineered. In Chongqing, a metro line runs straight through a residential tower, an everyday commute embedded inside architecture itself. Recently, during the Spring Festival Gala, humanoid robots executed synchronized flips and maintained flawless balance on stage. It was more than entertainment. It was a public demonstration of precision control, advanced robotics, and the normalization of automation in modern life. In Shanghai, 3 vertical icons stand within a single skyline: Shanghai Tower, Jinmao Tower, and Shanghai World Financial Center. A twisting aerodynamic form, a tiered neo-futurist structure, and a sharply cut geometric void. Different philosophies, one financial core. Together, they signal architectural ambition backed by economic scale. Then in Hubei, infrastructure moves beyond the skyline. The Wuhan suspended monorail glides above the city like a suspended transit grid. Down the Yangtze River, the Three Gorges Dam commands one of the largest hydroelectric systems ever built, while the Three Gorges ship lift raises 1,000-ton vessels vertically, turning elevation into routine engineering. When density meets automation at this scale, does a city remain a city or become a system? And if infrastructure can shape daily life this precisely, what does the next stage of urban evolution look like? This is mega-city expansion, where architecture, technology, and national strategy converge to redefine how the future is built. Rising at the dramatic confluence of the Yangtze and Jialing rivers, Chongqing has evolved into one of China's most vertically engineered and topographically complex megacities, where steep mountainsides dictate how every road, tower, and transit line must be conceived. With a metropolitan population exceeding 30 million residents, the municipality functions as the primary economic gateway linking Western China to the Yangtze River shipping corridor, anchoring logistics, advanced manufacturing, and inland finance within a single mountainous basin. Unlike coastal cities that expand across relatively flat plains, Chongqing is forced to stack development in layers: bridges crossing above bridges, expressways suspended over ravines, and residential clusters climbing hillsides in dense vertical grids. In this environment, urban expansion is not defined by outward sprawl, but by structural adaptation, where engineering precision determines how efficiently space can be multiplied within severe geographic constraints. Those geographic constraints explain why Chongqing's transportation network has become a three-dimensional circulation system rather than a conventional planar grid, with elevated expressways looping across valleys and metro lines threading between high-rise towers at varying elevations. Mass transit here does not simply connect districts. It penetrates terrain, tunnels through rock strata, and curves around cliff faces in order to maintain continuity across sharp elevation changes. Instead of demolishing dense neighborhoods to widen surface roads, planners adopted a strategy of vertical integration, embedding transit directly into existing architectural frameworks to preserve limited land resources. The most internationally recognized example is Liziba Station, where a light rail monorail line passes through the midsection of a residential tower between the 6th and 8th floors. A configuration engineered with vibration-dampening tracks and reinforced shear walls to prevent structural stress. Originally constructed as part of the city's early monorail expansion in the late 1990s, the station demonstrated how infrastructure could coexist with private housing without sacrificing operational efficiency. Advanced noise reduction panels and elastic rail fasteners minimize acoustic transfer, allowing trains to glide through the structure with surprisingly low interior disturbance. What appears at first glance to be architectural spectacle is in practice a calculated response to land scarcity and elevation differentials exceeding several hundred feet across short distances. In Chongqing, transportation is not layered beneath the city. It is fused directly into the urban fabric, transforming buildings themselves into components of a larger mobility system. Yet mobility alone does not define the next phase of megacity development, particularly in a city positioning itself as a testing ground for intelligent automation and applied robotics within complex environments. Chongqing's technology sector has invested heavily in balance control algorithms, machine vision systems, and adaptive locomotion platforms capable of navigating uneven terrain and variable surfaces, capabilities directly relevant to mountainous urban settings. These robotic systems rely on real-time sensor fusion, combining gyroscopic stabilization with spatial mapping software to maintain equilibrium under dynamic movement conditions. During the most recent Spring Festival Gala broadcast, humanoid robots developed by Chinese firms performed synchronized flips, rapid directional changes, and choreographed dance sequences while maintaining stable posture under shifting stage loads. The demonstration was not merely entertainment, it represented a public validation of precision control engineering, highlighting advancements in servo response speed and joint torque calibration. If a machine can recalibrate its center of gravity mid-air during a televised performance, it signals readiness for deployment in inspection, logistics, and high-density service environments. Such displays subtly communicate a broader strategic vision. Automation is being normalized as an extension of daily urban infrastructure rather than as an isolated laboratory experiment. In a city where geography already demands structural ingenuity, intelligent systems become the next logical layer of expansion. That synthesis of engineering and symbolism is further embodied by the Chongqing Grand Theater, positioned prominently along the riverfront near the meeting point of the Yangtze and Jialing waterways. Designed with angular glass facades and a steel diagrid framework, the structure resembles a crystalline volume emerging from the shoreline, reflecting changing light conditions across the water throughout the day. Its main performance hall accommodates more than 1,000 attendees, supported by advanced acoustic paneling engineered to distribute sound evenly across a wide seating gradient without electronic distortion. Beyond its technical specifications, the theater anchors a broader cultural redevelopment corridor intended to reposition the city's identity beyond heavy industry and logistics. Large-scale civic plazas surrounding the venue create open gathering space in a city otherwise constrained by mountainous density, effectively carving out horizontal breathing room within a vertical landscape. At night, programmable LED illumination transforms the facade into a luminous focal point visible from multiple bridge crossings, integrating the structure into the broader skyline composition. The building thus operates simultaneously as cultural infrastructure and as a visual counterbalance to the layered residential hills behind it. In a metropolis defined by engineering pragmatism, the Grand Theater signals that architectural ambition also carries symbolic weight. This trajectory of integrated density culminates dramatically in Raffles City Chongqing, a mixed-use megastructure designed to consolidate residential, commercial, office, and hospitality functions within a unified vertical cluster on the River Peninsula. The development comprises 8 high-rise towers linked by a horizontal sky bridge positioned nearly 1,000 feet above ground level, an elevated structural element engineered to distribute load across multiple reinforced cores. Rather than treating height as isolated vertical shafts, the project fuses towers into a cohesive architectural mass, effectively creating a suspended platform that redefines how volume can be aggregated in constrained terrain. The skybridge itself contains retail and public observation areas, transforming structural necessity into experiential space. Wind and seismic modeling inform the design to accommodate regional environmental forces common to southwestern China, ensuring long-term structural resilience. Viewed from across the river, the entire complex resembles a vessel anchored above the skyline, reinforcing the city's narrative of building not around geographic limits, but directly through them. In Chongqing, mega projects are not isolated landmarks, but coordinated components of a larger urban operating system, where transportation, automation, culture, and vertical density converge to transform geographic constraint into strategic advantage. What emerges is a city that treats elevation, infrastructure, and intelligent technology not as obstacles to manage, but as instruments of long-term vision, positioning Chongqing as a prototype for how mountainous megacities may be engineered in the decades ahead. At the mouth of the Yangtze River Delta, Shanghai stands as China's most internationally connected metropolis, functioning simultaneously as a global shipping nexus, a financial command center, and a high-density innovation corridor. Over the past 4 decades, the city has transformed from a manufacturing and port-based economy into a sophisticated ecosystem of finance, logistics, technology, and advanced services, with its GDP ranking among the highest of any city in Asia. The skyline of Pudong, rising across the Huangpu River from the historic Bund, serves not merely as an urban backdrop, but as a strategic declaration of economic scale, technical capability, and long-term geopolitical ambition. That architectural narrative begins with a structure that redefined the visual identity of modern Pudong. The Oriental Pearl Tower ascends more than 1,400 feet above the riverbank. Its distinctive configuration of 11 steel spheres arranged along a reinforced concrete shaft, forming one of the most recognizable profiles in contemporary Asia. Completed in 1994, during the early surge of Pudong's development, the tower was designed to consolidate broadcasting infrastructure while symbolizing Shanghai's re-emergence as a global commercial center. Its structural system distributes vertical loads through 3 massive inclined columns anchored deep into alluvial soil, ensuring stability in a region subject to typhoon activity and high humidity conditions. The spherical observation decks vary in diameter, creating both aesthetic rhythm and functional zoning for tourism, exhibitions, and dining facilities within a single vertical axis. A revolving restaurant positioned in one of the upper spheres provides panoramic views that encompass the colonial-era facades of the Bund and the rapidly expanding financial district behind it. High-speed elevator systems reduce vertical transit time, moving visitors from ground level to elevated platforms in under a minute, despite the tower's considerable height. A transparent glass skywalk encircles the lower observation sphere, allowing visitors to look directly down at the traffic arteries and river traffic below, reinforcing the sensation of suspended elevation. At night, a programmable LED illumination system transforms the tower into a luminous landmark, visible across kilometers of urban fabric. Beyond telecommunications utility, the Oriental Pearl Tower became a psychological milestone, signaling that Shanghai's future would be built upward as much as outward. However, as Shanghai's financial markets deepened and international capital flowed into Pudong, the scale of ambition escalated dramatically. The Shanghai Tower rises to more than 2,000 feet, making it the tallest building in China and one of the tallest structures on Earth, redefining the upper limits of urban verticality in East Asia. Completed in 2015, the tower's aerodynamic twisting form rotates approximately 120 degrees from base to crown, a design strategy that reduces wind loads by nearly 24% compared to a conventional rectangular tower. Its double-layered glass facade creates a thermal buffer zone that enhances insulation, reduces energy consumption, and contributes to advanced environmental performance metrics. The internal program is divided into 9 vertical zones, each functioning as a semi-autonomous cluster with sky lobbies that streamline elevator logistics across more than 120 floors. High-speed elevators capable of exceeding 40 miles per hour rank among the fastest commercial lifts in the world, minimizing vertical commute time for thousands of daily occupants. A composite structural core supported by outrigger trusses provides lateral stiffness capable of resisting seismic forces and seasonal typhoon winds common along China's eastern coastline. Rainwater harvesting systems and integrated wind turbines contribute renewable energy to on-site operations, reinforcing the tower's LEED Platinum certification standards. The building accommodates corporate headquarters, luxury hospitality, retail space, and observation decks, creating a vertically integrated economic ecosystem within a single footprint. Shanghai Tower is not only an engineering achievement, but a strategic asset, symbolizing the city's transition into a mature global financial powerhouse. Standing adjacent to it is a structure that once embodied that very pinnacle. The Shanghai World Financial Center reaches more than 1,600 feet into the Pudong skyline, distinguished by its trapezoidal aperture near the summit that reduces wind pressure while creating a highly identifiable silhouette. Originally conceptualized in the 1990s and completed in 2008 after design revisions, the tower was engineered to house multinational financial institutions, high-end hospitality, and public observation facilities within a vertically stratified layout. The large opening near the crown allows air to pass through the structure, mitigating vortex shedding and reducing lateral oscillation under strong wind conditions. Its steel megaframe and reinforced concrete core form a rigid structural skeleton capable of sustaining both gravitational loads and seismic stress typical of the Yangtze Delta region. Observation platforms positioned above 1,400 feet provide expansive views that extend beyond central Shanghai into the broader Delta Economic Zone. Internally, the building integrates Class A office space, a five-star hotel, and retail podiums, enabling mixed-use efficiency without structural compromise. During its early operational years, it held the title of the tallest building in mainland China, serving as a visible marker of Shanghai's accelerating financial liberalization. The clean geometric lines of its facade contrast sharply with the curvature of Shanghai Tower beside it, creating a visual dialogue between precision and fluidity. As a transitional icon, it bridges the early wave of Pudong's expansion with the super-tall era that followed. Yet before both of these structures reshaped the skyline, another tower laid the architectural groundwork. The Jinmao Tower rises more than 1,300 feet, combining traditional Chinese pagoda-inspired tiering with a modern steel and glass superstructure. Completed in 1999, the building is divided into 16 progressively narrowing segments, referencing classical Chinese architectural symmetry while accommodating contemporary structural engineering requirements. A reinforced concrete core works in conjunction with an external steel frame and outrigger truss system to provide lateral stability across its 88 floors. Within its upper section, a multi-story atrium hotel extends vertically through the tower's center, forming one of the tallest interior voids ever constructed at the time of completion. The facade's reflective metallic finish shifts in tone under varying atmospheric conditions, accentuating the building's step geometry. Jinmao Tower quickly became a flagship address for multinational corporations entering China's expanding financial market at the turn of the century. Today, positioned beside newer and taller neighbors, it serves as a generational anchor, evidence of the moment Shanghai first committed decisively to super-tall development as a statement of economic intent. Collectively, these four towers function as more than architectural landmarks. They represent sequential chapters in Shanghai's transformation from regional port city to global financial epicenter. In Shanghai, vertical construction is not merely about height. It is a calibrated expression of capital concentration, engineering mastery, and long-term strategic vision projected onto the skyline. The Wuhan Suspended Monorail represents one of the most technologically distinctive urban transit initiatives in Hubei province, developed in response to Wuhan's rapid spatial expansion and steadily increasing commuter demand. As the city continues to evolve into a major economic and research hub in central China, transportation infrastructure has become a critical strategic priority, requiring solutions that are both spatially efficient and operationally advanced. Unlike conventional metro systems that operate on tracks beneath the train, this suspended monorail utilizes a straddle-type configuration in which the train cars hang below a guide beam, allowing for a more compact structural footprint and reduced ground-level disruption. This design significantly minimizes land acquisition requirements while maintaining grade separation from road traffic, thereby improving overall safety, reliability, and system resilience in densely built urban corridors. From an engineering standpoint, the system integrates a high degree of automation, incorporating centralized control technologies that optimize scheduling precision, headway consistency, and energy efficiency. Automated train operations reduce dependency on manual intervention, enhance operational stability, and provide scalability should passenger volume increase in future development phases. The project is strategically aligned with the development of Wuhan's high-tech districts, particularly areas focused on research institutions, innovation clusters, and advanced manufacturing enterprises. By linking residential communities with business and academic centers, the suspended monorail strengthens internal mobility networks while reinforcing the city's broader ambition to position itself as a leading technological center in inland China. Urbanistically, the elevated yet lightweight structure creates a layered transportation system without imposing the visual and structural bulk commonly associated with traditional elevated rail viaducts. The relatively slender support columns and streamlined beam design help preserve ground-level continuity, maintaining pedestrian accessibility and commercial activity beneath the line. In a broader context, the Wuhan's suspended monorail serves as a pilot model for medium-capacity transit systems in emerging metropolitan zones, offering a balance between construction cost, operational efficiency, and long-term sustainability. Rather than functioning solely as a transportation corridor, it stands as a strategic infrastructure investment that reflects Wuhan's adaptive approach to smart urban development and future-oriented mobility planning. The Three Gorges Dam stands on the Yangtze River in Hubei Province as the largest hydroelectric power station in the world by installed capacity, representing one of the most ambitious infrastructure undertakings in modern civil engineering history. Designed to generate vast quantities of renewable electricity, the project plays a central role in stabilizing China's national power grid while significantly reducing reliance on coal-based energy sources in major industrial regions. Beyond energy production, the dam was strategically constructed to strengthen flood control along the Yangtze Basin, mitigating seasonal flood risks that historically caused extensive economic losses and humanitarian crises downstream. The massive reservoir formed behind the structure stretches hundreds of kilometers upstream, fundamentally transforming regional hydrology, reshaping river navigation conditions, and influencing economic development patterns along the corridor. Structurally, the concrete gravity dam was engineered to withstand enormous hydrostatic pressure, seismic forces, and long-term operational stress, demonstrating advanced large-scale construction capability and complex project management coordination. As an integrated water management system, the Three Gorges Dam functions not only as a power generation facility, but also as a cornerstone of national flood mitigation strategy and long-term river basin regulation. Adjacent to the dam, the Three Gorges shiplift was developed to overcome the substantial elevation difference created by the dam structure, ensuring continuity of river navigation along one of the world's busiest inland waterways. Unlike the traditional multi-stage lock system, the shiplift operates as a vertical elevator capable of raising or lowering vessels in a single continuous motion, significantly reducing transit time for medium-sized cargo ships. The system is engineered to lift vessels weighing thousands of tons within a massive water-filled chamber, making it one of the most technically complex and powerful ship elevators ever constructed. Its mechanical framework requires extreme precision in load balancing, synchronized lifting mechanisms, and structural stability to ensure operational safety under varying water levels and environmental conditions. By accelerating upstream and downstream passage, the shiplift enhances the commercial efficiency of the Yangtze River as a strategic logistics artery linking inland manufacturing zones to coastal export hubs. Together with the dam, the shiplift forms an integrated infrastructure complex that combines renewable energy generation, flood control, and high-capacity river transport within a single, coordinated engineering system. The Yangtze Suspension Bridge spans the Yangtze River in Wuhan, Hubei Province, serving as a major transportation artery that strengthens connectivity between key urban districts on both sides of the river. As one of the longest double-deck suspension bridges in the world, the structure was engineered to accommodate high traffic volumes across multiple transport layers, significantly improving regional mobility efficiency. The bridge features a steel truss girder system supported by massive suspension cables anchored to reinforced concrete towers, ensuring structural stability under heavy vehicular loads and dynamic wind forces. Its dual-level configuration separates different traffic flows, optimizing capacity while reducing congestion pressure on older crossings within the metropolitan area. From a structural engineering perspective, the bridge required precise aerodynamic design considerations to mitigate oscillation risks and maintain long-term durability in a humid river environment. Beyond its transportation function, the Yangtze Suspension Bridge has become a defining element of Wuhan's modern skyline, symbolizing the city's rapid infrastructure expansion and strategic role within central China's economic network. By integrating advanced bridge engineering with large-scale urban planning, the project reflects Wuhan's long-term commitment to enhancing inter-district connectivity and supporting sustained metropolitan growth. The Place in Beijing is a large-scale commercial complex known for integrating retail, dining, and entertainment within a highly recognizable urban landmark environment. Located in the Chaoyang district, the development was conceived as a lifestyle-oriented destination aimed at both international visitors and Beijing's growing middle and upper-income consumer base. Its most defining feature is the massive overhead LED sky screen installed above the central plaza, creating an immersive digital canopy that transforms the public space into a programmable visual environment. This expansive display system is capable of broadcasting themed animations, brand campaigns, seasonal celebrations, and synchronized light performances, turning the plaza into a high-impact advertising and event venue. Architecturally, the complex combines open-air pedestrian circulation with enclosed retail zones, encouraging extended visitor dwell time and diversified commercial activity. The integration of large-scale digital media infrastructure positions the place not merely as a shopping center, but as a hybrid space where retail strategy and visual spectacle converge. From a commercial perspective, the development leverages experiential marketing to differentiate itself within Beijing's competitive retail landscape, where consumer engagement has become as critical as product offerings. The plaza frequently hosts public events, brand activations, and holiday gatherings, reinforcing its role as a social node within the city's contemporary urban culture. Overall, the place reflects Beijing's broader shift toward digitally enhanced commercial environments, where architecture, media technology, and consumer experience are strategically integrated into a single coordinated platform. The China Central Television headquarters in Beijing stands as one of the most architecturally unconventional high-rise structures in the country, redefining traditional skyscraper typology through its continuous loop configuration. Designed as a headquarters complex for the national broadcaster, the building consolidates television production, news operations, administration, and broadcasting facilities within a single interconnected structural system. Its distinctive overhanging form required advanced structural engineering solutions to to manage cantilevered loads, seismic resistance, and long-term stability within a dense urban environment. Rather than emphasizing vertical height alone, the design prioritizes spatial interconnectivity, symbolizing the integrated workflow of modern media production and information exchange. Today, the CCTV headquarters functions not only as a core media infrastructure asset, but also as a landmark of contemporary architectural experimentation within Beijing's rapidly evolving skyline. Drone shows have emerged as a technologically advanced alternative to traditional fireworks displays, combining synchronized aerial choreography with programmable LED lighting to create large-scale visual spectacles in the night sky. These performances rely on fleets of unmanned aerial vehicles equipped with GPS positioning systems and centralized control software, allowing hundreds or even thousands of drones to move in precise formations with minimal margin of error. Each drone acts as an individual pixel within a three-dimensional canvas, enabling organizers to render logos, animated symbols, architectural outlines, and narrative sequences with high visual clarity. Compared to conventional pyrotechnics, drone shows offer significantly greater control over timing, spatial distribution, and environmental impact, reducing noise pollution and eliminating debris fallout. From a technical standpoint, advanced algorithms manage collision avoidance, real-time positional adjustments, and synchronized motion to ensure safety and accuracy throughout the performance. These events are increasingly integrated into national celebrations, corporate product launches, tourism festivals, and large-scale sporting ceremonies, reflecting their adaptability across industries. Energy efficiency and reusability further position drone shows as a sustainable entertainment solution, particularly in densely populated urban environments where safety regulations are strict. The scalability of the technology allows production teams to adjust fleet size according to budget, venue constraints, and desired visual complexity without fundamentally altering the operational framework. As software capabilities continue to evolve, drone shows are moving beyond simple light formations toward more immersive storytelling formats that blend music synchronization, branding strategy, and urban spectacle into a unified visual experience. Chimlong Ocean Kingdom in Guangdong Province is one of the largest marine-themed amusement parks in the world, developed as a flagship destination within China's expanding leisure and tourism industry. Located in Zhuhai, the park was strategically positioned to serve both domestic visitors and international tourists from the Greater Bay Area, including Hong Kong and Macau. The complex integrates large-scale aquarium exhibits, marine animal habitats, roller coasters, and immersive themed zones into a unified entertainment environment designed for high visitor throughput. Its signature aquarium facilities are engineered with massive acrylic viewing panels and advanced life support systems, enabling the display of diverse marine ecosystems at substantial scale. Beyond animal exhibitions, the park incorporates high-capacity thrill rides and multimedia attractions, broadening its appeal beyond traditional aquarium audiences and positioning it as a hybrid marine theme park. Operationally, the development required complex water filtration infrastructure, temperature control systems, and habitat engineering to maintain biological sustainability within enclosed environments. The park frequently stages large-scale performances, parades, and nighttime light shows, enhancing visitor engagement and extending average dwell time across the property. From a commercial perspective, Chimlong Ocean Kingdom represents a vertically integrated tourism model, combining hospitality, retail, dining, and entertainment within a single destination ecosystem. Its scale and infrastructure demonstrate China's capability to develop globally competitive themed attractions that rival established international entertainment brands. Overall, Chimlong Ocean Kingdom functions not only as a recreational venue, but also as a strategic tourism asset, contributing to regional economic growth within Guangdong's Greater Bay Area Development Framework. Beijing Daxing International Airport was developed as a major aviation hub to alleviate congestion at the capital's existing airports and to support the long-term expansion of air traffic in northern China. The terminal building features a centralized, starfish-inspired layout that minimizes walking distances for passengers while optimizing aircraft gate distribution around a single core structure. Engineered to handle tens of millions of passengers annually, the airport integrates advanced baggage handling systems, intelligent security screening, and high-capacity runway operations to maintain efficiency at scale. Its design emphasizes spatial clarity, natural lighting, and streamlined passenger flow, reflecting contemporary standards in large-scale airport planning and operational logistics. Beyond transportation, Beijing Daxing International Airport functions as a strategic infrastructure asset, reinforcing Beijing's role as a global gateway and strengthening regional economic connectivity within the Jing-Jinji metropolitan cluster. Infinitus Plaza in Guangzhou is a contemporary office complex designed to accommodate the headquarters operations of Infinitus, reflecting a corporate vision centered on continuity, integration, and long-term growth. The development is distinguished by its interconnected ring-like architectural form, which creates a continuous circulation loop and encourages internal collaboration across departments, within a unified structural framework. Engineered with a focus on sustainability, the building incorporates energy-efficient facade systems, natural ventilation strategies, and landscape terraces that enhance environmental performance and workplace comfort. The spatial configuration prioritizes openness and fluid movement, fostering interaction while maintaining operational functionality suited to a large-scale corporate headquarters. Beyond its commercial function, Infinitus Plaza contributes to Guangzhou's modern business district identity, representing the city's broader commitment to innovative architectural design and sustainable urban development. Guangzhou Circle is a landmark office building located along the Pearl River in Guangdong Province, recognized for its distinctive circular form that sets it apart from conventional high-rise typologies. The structure was developed primarily as a financial and trading headquarters, symbolically reflecting prosperity and continuity through its ring-shaped geometry inspired by traditional Chinese jade discs. Architecturally, the building features a large central void that reduces wind resistance while creating a striking visual frame within the urban skyline. Its steel structural system and reinforced core were engineered to ensure stability and load distribution across the curved facade, particularly given its unconventional geometry. Positioned prominently along the riverfront, Guangzhou Circle contributes to the city's modern commercial identity and enhances the visual character of the surrounding business district. Beyond its functional role, the building serves as a symbolic architectural statement, representing Guangzhou's integration of cultural reference with contemporary engineering integration. Yaxi Expressway is a major mountain highway in Sichuan Province, engineered to connect the cities of Ya'an and Xichang across one of the most topographically complex regions in southwest China. The route traverses steep valleys, high-altitude plateaus, and geologically unstable terrain, requiring an extensive system of tunnels and long-span bridges to maintain safe and continuous traffic flow. Due to dramatic elevation changes and frequent fog conditions, the expressway incorporates advanced monitoring systems, weather detection technology, and safety control infrastructure to enhance operational reliability. A significant portion of the highway consists of elevated viaducts and underground passages, reducing direct interference with mountainous landscapes while stabilizing the roadway against landslides and seismic risks. The engineering complexity of the project demanded coordinated geotechnical analysis, slope reinforcement strategies, and long-term structural resilience planning. By substantially reducing travel time between central Sichuan and the southern region of the province, the expressway has strengthened economic integration and logistical connectivity. Yaxi Expressway stands as a benchmark in high-difficulty highway construction, demonstrating China's capacity to deliver large-scale transport infrastructure in extreme mountainous environments.